Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Rob Thornton, president and CEO of the International District Energy Association. So, Rob, I really appreciate you coming on the program, and I'd like to have you tell our audience a little bit about yourself and about the IDEA.
Very good. Well, Aaron, thanks so much. It's great to be with you. As you mentioned, my name is Rob Thornton. I'm the president and CEO of the International District Energy Association. IDA was formed in 1909, so we're now beginning our 116th year of operations. We have about 3,000 members in 28 countries. The majority, though, are located in North America, US and Canada. Personally, I've been in energy my whole career. When I was a student at Tufts University, I wanted a summer job in Boston. I went to the financial aid office. They sent me to a small shop, Energy Policy Information Center. I showed up and they said, okay, kid, you study the greenhouse effect. So that was 1978. God bless Jimmy Carter was in office. It was the moral equivalent of war, the second oil embargo. We were being told to put on a sweater and conserve energy, and the greenhouse effect was real. It's we know it now as climate change, global warming. I had an epiphany that really our energy policy needs a lot of work, and it felt like this is a place where I could make a difference and maybe make a living. And so fast forward, here we are, almost 45 years later. I've been in solar, geothermal, but district energy for about 40 years, developed systems in cities, and I've been serving as CEO of IDEA since the year 2000. So coming up on 25 years
Wow.
in this role. It's hard to believe, but yeah. So I've kind of been an energy nerd. I'm not an engineer, son of an engineer, and I know just enough to be dangerous on the technical side.
There's a lot going on in district energy, and I think it's a really important topic to get out in front of people because I think there's a lot of efficiency savings that can go
Right.
along with it. And obviously, as you said, the IDEA has been around since 1909. So how have things evolved over that amount of time? Obviously, you weren't around for the early years, but in the time you have been there, I'm sure a lot has changed. So can you talk a little bit about what you see today and what's really important to address decarbonization challenges and things like that?
Sure. Yeah. So, I mean, I think the blocking and tackling of district energy remains the same. Actually the theme for our conference this year is aggregate, integrate, innovate, and that's essentially what we do. We aggregate the thermal loads of dozens or hundreds of buildings in a city, campus, community, and then integrate technologies. Sometimes it's a large heat pump. Sometimes it's waste energy, energy recovery, lake water cooling, CHP, surplus heat from power generation. So we integrate these low carbon technologies at scale, and then we innovate and we help the buildings become sort of more efficient users, more resilient community. Oftentimes there's a power generation component, a CHP asset in the mix. And Aaron, when IDA was formed in 1909, really, district energy was CHP in cities. The Edison companies were making power and heat in New York City, Boston, Philadelphia, San Francisco, etc. And then in the 1980s, the electric industry, they began to divest of their steam systems. No longer really, as they were scaling up, it didn't necessarily fit in their business model. And so a whole infusion of capital and innovation and entrepreneurs came into the industry. Those systems are still thriving today. And district energy fundamentally was one of the first environmental strategies for cities. At the turn of the century, or even before 1880, every building in a city had a coal furnace, and it was huge emissions, and air quality was really quite dangerous for the citizens. And so by consolidating into a central plant, distributing heat rather than having, a few hundred, unregulated boilers in a city, district energy was a means to improve air quality and reduce the risk of fire, conflagration, etc. So today, you asked me about, where are we now? District energy is really being recognized as a strategy, a tool, a technology, a range of technologies that can accelerate decarbonization for cities, doing it on a scale of investing in the central plant, maintaining the thermal network. If there's already a grid, you don't need to replace that necessarily, but shifting the production capacity to lower carbon solutions like heat pump or electric boilers or even renewable heating cooling from the community. It turns out that district energy is a way to get to decarbonizing dozens, if not hundreds of buildings at scale. One quick example. We're outside of Boston. Vicinity Energy recently completed commissioning of a 42 megawatt electric boiler that'll basically utilize renewable power that's available in the grid. Their plant is connected at a wholesale level, and that unit itself can cover about 30 million square feet of customer space. And so, they can deliver now low carbon steam to 30 million square feet of buildings. There's about 200 million, 220, I think, currently served in Boston, Cambridge. So that won't cover the whole range, but that boiler was designed, constructed, commissioned, operating in less than 2 years.
Hmm.
And, that's a very short timeline to actually get to low carbon, thermal for a city. So I think people are recognizing district energy is, near term, the fastest way to get cities to near or net zero.
As far as the number of cities that utilize this, you talked about how back in the early days, that's kind of how they built their downtowns. They had district energy in New York and Boston and all these East Coast cities. Is it common throughout America? Are most of the cities in some way utilizing district energy?
Yeah, there's over 600 operating district energy systems in the U.S. and that's in cities, also on college and university campuses, healthcare, military bases, airports, pharma, even our sort of newer industries like Meta, Apple, Google. Their campuses are utilizing district energy because, frankly, there's economies of scale. Rather than having every building with a boiler or chiller, cooling tower, all that equipment and the capital, the operation, the maintenance, the replacement, aggregating and consolidating, there's economic and operational advantages to district energy. So in the US, most major cities have a district energy system, and it's a huge advantage if there is a thermal grid underground. Canada, Toronto, Markham, Vancouver, district energy is actually quite ubiquitous, but not that well known. We're not visible. Basically, the assets are largely underground, and so we don't necessarily have I think the visibility opportunity of like a wind turbine or solar panels, right? So we quietly, do our work. But I would guess that for the listeners on this podcast, if they went to a college or university in North America, I'd bet 8 out of 10 lived in a dorm that was supplied by a district heating system. So it's really a lot more common than people realize.
Right. And what are some of the main technical and maybe financial barriers when it comes to retrofitting existing urban infrastructure and implementing a district energy system, for example?
Yeah, I mean, if you've ever been in New York City and seen an excavation, like there's a whole city subterranean, underground, and so there's just huge congestion under the streets with, think about it, deep down there's a subway, above that is a wastewater line, above that are power banks and ducts, and then sewer, water, district energy, fiber, there's like a whole infrastructure living underground. So one of the things I think has come to home to roost, we've heard the term in recent years like, oh, let's just electrify everything. Well, it turns out that's not that simple because, if you're going to take buildings that were, let's say they were served by district energy or maybe had gas boilers and you want to put them on the grid on electricity, then that means the electric grid probably isn't adequate to have a threefold or more increase in electric demand, right? So the wires aren't adequate. So that means substations and additional just duct banks, right? So everybody, sort of has to compete for right of way. Now, the advantage of district energy is that you can move a lot of heat and cooling, through existing pipes, and there's diversity, within a city. So if you're serving, let's say, 20 million square feet in a city, not all the buildings are going to have a peak demand at the same time, right? So if you have an event load like an arena or civic center, hospitality, hotel, retail, office, residential, there is sort of like a Lego block of uses. So you can actually generate or deliver a yield of, sort of, you can cover more square footage with the same sort of, pipe diameter, as long as you're managing the energy intense, helping manage the energy intensity, of the consumers of the buildings on the system. But you're right; it's not for the faint of heart. Trying to put infrastructure in cities requires, a very thoughtful engineering planning analysis. We are seeing, though, all across the EU, significant investment and growth. London, Berlin, Germany, Hamburg, uh, Sweden, Denmark, etc. In the EU right now, in particular in Germany, there's a requirement that cities with a population more than 10,000, I think it is, citizens, must implement a heat plan, a heat map. And that's intended to kind of identify, well, are there sources of heat that are already available in the economy that we can tap and utilize? In London, for instance, they take heat out of the subway, the tube, and they use that to heat buildings. Instead of it being like a waste product or a problem, they're converting it into a usable source of energy. We're going to see the same thing here in North America with data centers. Data centers, as you appreciate, generate huge amounts of heat, low grade heat, but 24/7, 365. Right now, that's a cost, to kind of dissipate that heat. If it were co-located with district energy, it becomes a useful source. So what's happening is there's a recognition that thermal energy has value, and what is happening now is that communities are looking at thermal grids as a means to reduce the emissions produced in their like regional economy. But like, make no mistake, it's not a simple endeavor to build a district energy system from scratch. But we are seeing it happen. And finally, since 1990, here in the U.S., I think we've seen nearly 100 district cooling systems built. These are central plants that produce and deliver chilled water, supply and return, to customer buildings, in cities, campuses, communities, etc. And it turns out that district cooling is a huge opportunity, not only here in North America, but around the world, particularly in regions like the Middle East, Dubai, Abu Dhabi, Doha, where cooling is critical. So I jumped off your question, went to some other tangents,
No,
and maybe
it's
it didn't even answer your first question.
well,
But
it's great information regardless. And I actually you brought something up in my own mind because we just published a story in our January issue about a German museum that's using wastewater heat or
yes,
heat out of the wastewater to basically heat and cool the museum. So it's really interesting how some of these projects come about and what they can do and how they can really provide some great efficiency for the overall system.
yeah, and if you think about it, Aaron, if you're utilizing kind of sort of an available asset, you're essentially converting a problem into an asset, a deficiency into an asset. That enhances the local economy, the balance of trade. So rather than buying, either fuel or resource, from outside the local economy, it's sort of, staying within the circular economy. And particularly, we are seeing a real surge in interest in recovering heat from sewer lines and wastewater. In Markham, they've just launched recently a very significant wastewater district energy system. The city of Markham owns the district energy system, the network there, and the sewer line literally runs right through the parcel where the main plant is located. So it's kind of easy to harvest. And the Western Center outside of Denver, where the stockyard used to be hosted, that's now become a thriving, sort of multi-use development sector, again, utilizing with heat pumps, taking heat out of the sewer line and using it to make heating and cooling. So, our members are really investing in technologies that can simultaneously provide heating and cooling. Stanford University, their central plant now, when they're making cooling, it's actually producing heat. And so they put the heat into the thermal grid, and that's used in buildings for showers and process and, sometimes humidification. And then when they're making heat, it's kind of inverse. So when you have the kind of the bicameral mind, right? You can utilize heat and cool in a network. And the other thing that's happening, a significant, I think, investment trend, particularly in our college and university campuses, is geo-exchange on scale. So schools like Oberlin College, Princeton University, Carleton College, Smith College here in Northampton, Mass, making huge investments to shift over to geothermal heat pump networks to provide heating and cooling, for their campuses. Mm-hmm. So district energy is really the enabling technology, right? By interconnecting dozens, hundreds of buildings, that creates an economy of scale that allows for an investment like this to make economic sense, rather than, I think sometimes the duplicative requirement of every building doing it themselves. There's huge advantage to having the aggregation and scale.
Right. And I think most people can understand how, it's very easy to implement this sort of a strategy in a dense urban area. But when you get out into the suburbs, for example, it's maybe a little more difficult, but still probably not impossible. Do you just have smaller systems out there where maybe there's a mall and a few office buildings that can tie together? Or how does it work when you get into these more spread out areas?
Yeah, it's so interesting there, like in Copenhagen, right, Denmark. I think in downtown Copenhagen, like I think it's 98, almost 99% of the buildings are on district heating. But then when you go out into the communities, sort of more like suburbs or exurbs, and it's single family homes, those systems are owned by the users, the municipalities. They're structured in a way. It isn't necessarily the same. The densities are probably different than you might see, like in Minnesota, the Twin Cities, where in some communities there's like 1 acre zoning, right? So the density, is might be a challenge. But when you have a cluster, a community, we've seen in the U.S., particularly, after Superstorm Sandy, where the resilience became a critical mission. Communities wanted for the supermarket and the gas station and the fire station, the police station, and maybe the hospital, to be kind of linked with either a thermal grid or a microgrid. So there was local generation. They weren't relying on a power plant and a transmission line from 100 miles away. There was some megawatts right there in the grid. And those megawatts, while producing power, also generated heat. And so, I think, when communities, faced with more extreme weather events, whether it's extreme cold, polar vortex, or, what we've been seeing lately is, really unparalleled continuous heat demand. Having a district energy network really does, I think, provide both efficiency as well as resilience, in the communities. But to get to your question, yeah, it becomes a little more challenging. I mean, the piping components are different. They're not, our colleagues in Europe, in EU, have really developed some very innovative piping technologies where it's sort of a single tube with both a supply and a return insulated pipe in. And it's spooled, so it kind of comes off a truck. It's not necessarily welded. It can be fused. So the cost for distribution, to kind of connect and link dozens of customer buildings isn't the same as it would be in with a deeper excavation, in a central city, right, where the underground is coagulated or challenging. So definitely, there is a density where district energy makes really good sense, and then there's times where it's maybe marginal, but there could be opportunities for like either clusters or contiguous, or in the case of, let's say it's a community that might have a sewer line, right, that's running nearby. Maybe it's a wastewater trunk, a regional trunk. Maybe there's a lake or river that could provide a source of renewable cooling. There really are. I think the one thing that district energy is best at is identifying local resources so that the system is designed to utilize kind of what's available in the local economy, whether it's biomass or or methane, from a large cattle ranch, or just a community of cows, uh, or data centers. Like if you're in
Right.
Northern Virginia, I saw recently that the Northern Virginia Regional Commission has that. I think there's 350 data centers in that part of the world, and that's a lot of heat being generated. So they've actually said they'd like for these clusters to be harvesting heat and utilizing them. I think that's something we're going to see near term, where data centers and district energy are like chocolate and peanut butter. They go together. Forrest Gump might have said like peas and carrots.
Yeah.
I think we're going to see that convergence accelerate.
Yeah. Well, I hope it happens sooner rather than later because I think there is a lot of opportunity there. So that's good to hear. Can you talk a little bit about thermal storage and how
Yeah.
that's maybe making district energy systems more resilient and efficient?
Here in the U.S., a lot of district cooling systems have like large tanks above ground, stratified. So they're making cold water or ice even at night when equipment runs more efficiently. The cost for electricity is typically lower, and then that chilled water that's produced, the night before or the weekend before, is used to provide cooling to buildings during the afternoons, particularly in summer afternoons when the price of power gets increases, can grow tenfold. And then actually having a kind of a volume of chilled water available can augment or supplement if the demand were to escalate. Well, I worked for the district heating and cooling system in Hartford for 5 years in the late 1980s. We converted a 1.2 million gallon what was an oil storage tank into a chilled water storage tank. And that became particularly valuable during a period of time where we had 10 days in a row with outdoor temperature was over 100 degrees. That just really is not that common in Connecticut, Hartford, Connecticut. But what had happened too is that put tremendous strain on the power grid. Even the Connecticut River, which was our source of condenser water, the plant didn't have cooling towers. It supplied chilled water to about 70 buildings downtown, including data centers for the large insurance providers. But the Connecticut River, the temperature of the river was up around 88 degrees, and the design temperature for condensers, top is 85 degrees. And so power plants were actually shutting downriver because they were not able to sufficiently cool. The capacity was constrained.
Hmm.
So having the chilled water, the thermal storage tank, allowed us to kind of build a reserve, during the night when, I mean, the river didn't, cool by 5 degrees from day to night, but everything kind of operated just a little bit better at night when, the outdoor temperature was substantially lower.
Mm-hmm.
that saved our bacon. And we asked our customers just, kind of stay online, don't shut down over the weekend, don't have a surge on a Monday morning, just kind of run this like a marathon, not a sprint. And we got through it. So thermal storage is widely used on our large campuses. UT Austin, even the Texas Medical Center, Houston, serves 6 teaching hospitals, huge campus. Thermal storage is critical to their efficiency and operational, integrity. So again, it allows you to make a product, you decoupling the production from the use. And that's going to be even more important as we move into a paradigm where there's more time of use rates on electricity, and we're seeing even now an increase in the cost of power demand. So being able to mitigate that will, I think, kind of grow in value.
Mm-hmm. What about policy frameworks? Obviously, we had the inauguration yesterday, and we've got a new administration now that's probably got a different focus than we previously had. Is there anything in the works that you think is going to benefit the district energy adoption?
We expect that the pendulum is going to, swing pretty, significantly from like a federal policy, the administration executive order removing us from the Paris Agreement, etc. What's I think interesting about district energy is we've kind of always we haven't relied on either tax credits or tax policy to to grow and sustain our businesses. It's helpful when it's available, but it hasn't really been a principal driver. Some of our systems have leveraged funding from the Inflation Reduction Act (IRA) to offset the capital costs of hybrid systems. I think that what's most interesting about district energy is fundamentally we're about efficiency and resilience and environmental performance. And so I don't think that even with a shift in the White House, I don't think that we're going to see just a total collapse of investment in clean energy. Maybe I think there'll be some adjustment. We do expect that perhaps systems that operate on combined heat and power or cogeneration, like harvesting heat, but at the base fuel might be natural gas, but the plant is operating at efficiencies of 70, 75, 80, 85%, efficiency, fuel in, 85% useful energy out. It could be that CHP comes back into vogue with the U.S. Department of Energy and EPA. So, I think where we sit, we're kind of right in the middle. Our systems are, zero carbon, decarbonizing assets, but also, generally efficient and resilient. And so efficiency and resiliency, I think they're never going to go out of style. It could be skinny tie or wide tie, but fundamentally, maybe people aren't wearing ties anymore. But I think that what we do and we do well is utilize resources, water, fuel, electricity, just more efficiently. And that's going to have both economic and environmental benefits. And sometimes the policies recognize it, and sometimes we have to do a better job of explaining, how these assets create and deliver value. So I think we're going to have a lot of work to do, but it isn't that, I don't feel like district energy is in a place where we're like really now swimming way upstream. And I do think, Aaron, to be truthful, we're going to see in some like states and cities probably even a doubling down in terms of assets like this to accelerate decarbonization and achieve objectives like Paris Climate Agreement. So it's going to vary locationally, but that's always been the case here in the U.S.
Right.
50 states, so many different regions. So it's a little hard to get to prognosticate, but I think we're good at what we do, and I think that the value of what we do will continue to be recognized and opportunities I think will grow.
Right. You make a good point that efficiency never really goes out of style. The better you can operate your plant and the money that you can save for customers and for companies is always beneficial. So as long as you're making steps in those directions, you're going to be fine.
Right.
How does the cost benefit analysis work out for district energy compared to other decarbonization strategies and like how long does it take to get payback from these types of systems when you implement them?
Yeah, I mean, that varies with the scale and the technology. I mean, district energies are essentially a long life asset, right? So the piping networks have a useful life of 50, 60, 70, 80 years. It's inert, well maintained, good water quality and maintenance. Those are long life assets. The plants, can be, and we've seen this in our history. The plants can, the generating capacity can be replaced over time. So, is the useful life of a compressor 20 years, 15, 30? We have chiller plants that are, operating large chillers, 5,000-ton chillers that are actually still performing at very high efficiencies, and they're 30, 40, 40 plus years old. So the district energy plant probably will evolve with a hybrid asset base. So there may be, a base load unit that is, sort of running like 6,000 hours a year or maybe 4,800 hours a year. And then, a mid-range asset that's utilized for either, increase in demand. And then some assets that are deployed for peaking, and that might be storage or even a small generating unit of some kind. In terms of investment, I'll give you a case example. Cornell University in the year 2000, they invested at that time a significant amount in a deep lake water cooling system. Instead of buying electricity from the grid to run electric chillers, they began to take cold water out of Lake Cayuga, run it take the cold water out of the bottom of the lake, run it to a heat exchanger building, 1 mile from the bottom of the lake to the heat, and then 2 miles uphill to the campus, and basically traded an electricity bill for a bond payment. Right, so they bonded this deep lake water cooling plant, and I think they had 20-year bonds to start. They recently, Cornell, I think within the last 2 years, did a forensic analysis of that investment. And they found that not only had the plant performed economically more efficiently than designed, but environmentally better than designed. And the bonds were retired in less than 15 years. I think it was like 14 years. Now, for a commercial entity, a 14-year sort of return on investment that's not adequate. What is that compounding 5.5%, 6% a year? But if you're an infrastructure fund or a municipality or in particular an institution that is going to be in that location for another 150 years, then these sorts of investments make terrific sense. But district energy, it isn't necessarily a payback. It's more like a return on investment, and that's a combination of debt and equity. But generally these assets have a return in the low teens, 8, 10, 12%, which it's not a high flyer. It's not going to be Nvidia or a tech stock, but it turns out that infrastructure funds, pension funds, sort of long life capital equity funds really value these types of assets because the revenue is generally assured, the switching costs are high, the returns are predictable, they grow over time, and it turns out that district energy is attracting billions of dollars of both private equity and pension funds because these assets have essentially predictable, stable return profiles. So Again, it's not easy to launch a district energy system. It does require a front end capital investment. That sometimes can be the challenging part, aggregating. But we're seeing in communities like development communities in like near Toronto, for instance, where there used to be a large steel facility or a lakefront asset is, it's now being kind of redeveloped, and district energy is the fundamental infrastructure that's being utilized because people want to live, work, play in locations that have predictable energy costs, are lower carbon footprint, and that don't require sort of or don't have the risk of replacement or the hassle of maintenance or use up useful space. District energy, if you own real estate in a city and you have the option to connect to district energy, it's a huge advantage because you don't have the risk of converting your space over to heat pumps and all the disruption and maybe maybe tenant issues. uh, you're not exposed to the volatility of the retail electricity market, where the price for a kilowatt hour may be, I don't know, 6 or 8 cents all in, depending on the region,
Mhm.
in April, and 50 cents in August, right? So if even building owners really prefer the predictability and stability. Now, it's not to say that the cost of energy doesn't vary, from with some seasonality or even time of day, but a district energy system can, essentially harmonize that, and again, spreading both the capital and the operating costs over a base of users really does have economic advantage. But if you're a building owner, what we're seeing, particularly in the Middle East, if you can reclaim the rooftop and replace the cooling towers or condensers with a rooftop restaurant, bar, pickleball, hotel, pool, man, that went from a cost center to a huge profit center. Downtown Chicago, it's the old post office building, has the highest leasing rate in the city because they're connected to the district cooling system and we're able to reclaim rooftop for tenant amenity. So that's a value component. It's not necessarily in the operating expense or the return, but the value add of district energy can be significant on a locational basis.
Mm-hmm. Very interesting. So we talked a little about data centers and what the opportunities there, to kind of capture some of that heat. Is there other opportunities as far as supplying these data centers with district energy in some way that would benefit them as well?
Yeah, I mean, I think to be realistic, there's like two types of data centers. I mean, there's more than that, but you have retail data centers that exist like in center cities, right? And they're serving, the local bank or the retail or basically the needs of that local economy. And then you have the hyperscalers, right, that are sort of the remote 100 megawatt data centers. Those are being built out sort of outside of, maybe dense urban locations. The hyperscalers, I mean, you read the headlines about them, connecting, using, renewables as their primary supply, or which is great. We're totally in favor of that. But these data centers, it turns out they actually need firm electricity supply. Like they're not really able to rely on the intermittency of, solar or wind. And so they have to be connected to the grid. And generally on the regional grid, that's going to require additional capacity. Transmission lines take a long time to site and build and deliver. So what we're actually seeing is in the near term, and I think, it's going to be natural gas, generation supporting this kind of near term proliferation of AI driven data centers. So that's an opportunity for district energy because we can harvest the heat out of a cogen unit, put it to use for district heating to nearby buildings. It can be used for urban agriculture, hydroponics, process, any any range of sources. And I think that'd be a missed opportunity if they were simple cycle, units just making power and dumping heat.
Mhm.
That would be kind of sad, frankly. You read the headlines and you hear about the hyperscalers, looking to harvest power from repurposed or renewed, large nukes. 3 Mile Island being one story. That's fine, but the time scale on that, I think, is still to be determined, right? So if the data center is going to be built and operable, and it may not be at 100% capacity day one, they're gonna need nearby local, reliable, resilient, power. So we see significant opportunity for district energy to be complementary, use. Well, in fact, Aaron, recently, a few months back, there's a proliferation of data centers in Dublin, Ireland. And one of the large hyperscalers was actually told they were not going to get a permit for their data center unless and until they were using the heat for district energy, right? So it's interesting that we're seeing now recognition that this heat has value and that by itself, it's a cost center, but when the heat can be utilized with either, kind of a heat pump to polish and improve the heat, or use it for heat and cooling, district energy really becomes sort of the aggregating, integrating, technology that I think can reduce downstream emissions, generate efficiencies, and provide economic benefit, both to the grid and to the local community. So I think we're on the doorstep of a significant surge
Mhm.
here.
Very good. So, how do you see AI being used to potentially optimize and help transform some of these systems as well?
Yeah, yeah. Well, it's actually our colleagues in Dubai, Empower. They operate the largest district cooling system in the world. In downtown Dubai, I think they have like 80 plus district cooling plants. They're all interconnected, at least on a control basis. The piping networks are not all interconnected, so it's not one big chilled water grid, but it's a series of networks. But they're all controlled at a central operating facility, and it's kind of like they have a full wall of screens, and it's like Google Earth. You can kind of click on a part of the city and see what the flow rates are, chilled water supply and return to like a cluster of buildings. Then you can click again. Basically, like getting tighter. You can look into the building and see how that building is using, chilled water supply and return. Then you can click deeper and look at even the air handlers in that building. You can click deeper and see, is there kind of a clog or a filter or some imbalance where that segment of the building is operating at a low delta T. They're not putting as much heat back into the loop as they should by design. And so and that's like machine learning in practice. That system has been operating, it's probably like 5 or 6 years now. And so AI is and has been implemented in district energy, globally. In some places with, I think, a lot more pace and attention. Our colleagues in the Middle East are really driving, efficiency at scale. Our friends in the EU, Germany, for instance, really a great deal of technology being applied and machine learning. But even our friends at Princeton, for the past, I don't know, 15 years, and at Harvard, these district energy systems at campuses, they're connected to the grid, and so they get a price signal from the grid, like what is the price of power, and is it more effective for us to make the power or purchase, consume, and but they're also now receiving from the New England ISO, both in New York and New England, a carbon signal. So every 15 minutes, or it might even be a 5 minute interval, they get their algorithm will make note of, can they produce heat and cool and power at a lower incremental carbon intensity than the grid. And and it turns out that most of the time they can produce energy at a lower carbon intensity when you integrate both power and heat, or cooling power and heat. But as college and universities, they are really making investment to decarbonize and achieve significant carbon targets, right? Emissions on campus. So they're making these investments both in AI and technology as well as equipment to reduce their carbon intensity. But having the scale of a district energy system enables them to make decisions on either or carbon or price. And they can do both. And if they're in a good position to hit their carbon targets, then they can focus on price, or vice versa. So, we think that district energy, and there are we're holding our campus energy conference next month in Boston. There'll be about, I don't know, 1,400 people attending. Hope you're able to join. Maybe, I know you're planning, Aaron, to come to our annual conference in Minneapolis in June.
Right.
But what's really, really, I think, encouraging is you see the beehive of collaboration and integration and technology and scale that happens at an IDEA conference, where these are people of common interests, and they're really trying to help each other succeed. And so it isn't like they're necessarily kind of competing in the marketplace, but the technology providers they're retooling their heat pumps to deliver higher temperatures at higher COPs. The integrators are developing technologies to optimize around carbon or price, etc. And we have, I think, like 150 different technical papers being presented by people that are implementing these strategies real time to achieve both the efficiency, resilience, and the environmental targets that are possible with district energy. So AI is actually, it's working, and our members have been deploying it now for quite some time, really with great success. Just kind of doing it quietly, not looking for headlines, but it's really encouraging to see that they're walking the talk here in the IDA community.
It's exciting to go to the events like IDEA holds to learn from the people who are out there doing it and kind of get ideas on what's being successful, and kind of visualizing what maybe a new community could do with the resources that they have available. And I think there's a lot of interesting exchange that goes on at these events. So
yeah, thank you.
I've taken a lot more of your time than I expected, but is there anything that we haven't talked about that you feel is really important to touch on before we wrap up?
Yeah, well, thanks, Aaron. I really do appreciate the opportunity to chat with you and your audience, and invite them to come to districtenergy.org. Look around. We have like a great deal of resource. We have a blog where we harvest news from around the globe. There's so much work underway in our space. It's really exciting. I mean, I've been in district energy now for, let's see, 87, 47, 48 years now. It's hard to believe. I was a kid once here, but the pace of change really is exciting. I think I entered this industry really out of a desire to kind of do something about climate change and global warming. I think we have a lot more work to do, but I think district energy is going to be an important tool in our quiver to get there. We're seeing we're going to have like 3 planks at our annual conference in Minneapolis in June: data centers and district energy and nuclear. How can small modular reactors support low carbon heat in communities? Helsinki is making huge investments in that technology right now. And then the third plank is geothermal and district energy. Again, leveraging the scale for communities and cities, campuses to, build, boreholes, aggregate that investment, connect it to a heat pump plant, and achieve coefficients of performance to put heat in the ground during the summer months when you need cooling and take it out in the winter. It's really just kind of harvesting as opposed to dissipating that energy. We're seeing huge opportunity there. And while we're seeing states implement policies to encourage electric and gas utilities, the regulated utilities, to kind of make the switch or convert or invest in district energy thermal networks. IDA, we're firmly committed to helping them in that transition so that they're financially sustainable, not just rate based or pilot projects, but our members really do have the experience to build, own, operate these assets so that they really are both long life, as you mentioned before, like durable assets, but economically, valuable, so that the investments have return for all the stakeholders, the communities where they serve, the investors that put their capital in, and really, the local environment that sees the benefit of a more efficient technology. So, I welcome your readers to visit districtenergy.org and, kind of keep an eye on the International District Energy Association. We really do appreciate, Aaron, this opportunity to talk.
Again, for listeners, I've been speaking with Rob Thornton, President and CEO of the International District Energy Association, and I really appreciate your time coming on here speaking. And I'm really looking forward to the event also, because I think those pillars that you mentioned, data centers, nuclear, and geothermal, are all really important topics, yes, and they're really important to our audience. So I hope people will consider attending as well. Rob, again, thanks for your time. It's been a pleasure speaking with you.
Same here. Stay well, Aaron. Thank you.